So in this reaction, you see the double bond between the carbons, which is a sign that you're going to do some type of addition reaction. What specifically you're going to add depends on what you're mixing with the carbon chain. When you see two separate steps, the first of which is O3 or ozone, and the second of which is DMS or dimethyl sulfide, you know you're doing ozonolysis. So you're going to break apart that double bond and add or insert two oxygens where it was in its place. So in ozonolysis, it's a little unusual. You break apart that double bond, sort of karate chop that double bond in half, and where the double bond was, instead of going to each other, the double bond goes to two oxygens. So that would really be your product. Now, the problem with this is drawn in a very not unstandardized way. So you would want to be able to redraw this in a more standardized, common way. That's often how it would be presented, especially in standardized tests that are multiple choice. So as you do that, one way to translate this sort of non-standard way of drawing this molecule to a more standard one is to number the backbone. Now this is not a backbone like in terms of naming molecules, where you have to be very particular about what the backbone is and how you start numbering it. Instead, this is just a way to keep track of things, so you can number this however you want. So for example, you could start numbering it at the top right and sort of work your way around the molecule. Oops. So you'd have a total of, for example, you could have a total of 7 carbons there. And this is not the longest chain you can find. It's not numbered to give the first functional group the lowest number. We're not numbering this in the way that we do to name it. We're just numbering it in order to keep track of things. And so if I wanted to redraw this molecule, I can just draw a 7-carbon chain. So there's 1 carbon, 2, 3, 4, 5, 6, 7. And just for myself, to keep track of where everything is, you can put the numbers for each of those carbons below. And we have a double bond to oxygen on carbon number 2. So we can write that in and create that double bond to oxygen on carbon number 2. Then on carbon number 4, we have an isopropyl group. So on carbon number 4, we can draw an isopropyl group. And finally, on carbon number 6, we have a sort of ethyl group. So we could draw an ethyl group on carbon number 6. And then lastly, on carbon number 7, we have a double bond to an oxygen. So we could draw that in on carbon number 7. So we have the same branches at all the same points, and that means that these are the same molecule. And so your final product, drawn in a standardized way, would look something like that. So when you're doing an ozonolysis, especially if you're breaking open a ring, one thing you might consider is numbering a carbon chain and then redrawing it and seeing if the same branches are coming off the same places. But with an ozonolysis, you're breaking that double bond and you're adding double bonds to oxygens on each of those carbons that were in the double bond in its place.